This video is going to look at acceleration, which is the change in velocity of an object over time. The equation we're going to use is acceleration equals the change in velocity divided by the change in time. Since we haven't talked much about velocity, I'm going to tell you that it's the object's speed and its direction, which is usually indicated in square brackets. The example we will look at involves some information from the Tesla Model S, which is a really interesting electric car that's come out in the last few years. Tesla claims that the car can accelerate from 0 to 100 kilometers per hour in 2.7 seconds, and we're going to find the acceleration. So the car will accelerate in the eastward direction, and it's starting from rest, so that means the initial velocity is 0 kilometers per hour, and the final velocity is 100 kilometers per hour. The total time took 2.7 seconds, and we're going to look at what is the acceleration in meters per second. Notice that the units of speed are kilometers per hour, and time is measured in seconds. We need our answer in meters per second. That means we have to rewrite our speed in meters per second. We do this by unit conversions. 0 kilometers per hour is also 0 meters per second. And 100 kilometers per hour, from a unit conversion, I got 27.78 meters per second. Now we can rewrite our formula. Acceleration equals the change in velocity divided by the change in time. We can expand the change in velocity as the final velocity subtract the initial velocity divided by the change in time, and we can substitute our values now. 27.78 meters per second. 0 is the initial velocity, so we don't have to write that, all divided by 2.7 seconds. When we do that calculation, I get a number of 10.29 meters per second squared. Now we have to go check how many significant figures our final answer should have. If we're looking at 0 kilometers per hour, there's really no significant figures there. 100 kilometers per hour has one significant figure, and 2.7 seconds has two significant figures. Our final answer must be written with one significant figure. The acceleration equals 10 meters per second squared. Now there's something called deceleration, which happens when an object is slowing down. In this example, the car has an initial velocity of 50 kilometers per hour, and it's coming to a stop. At rest, the final velocity will be 0 kilometers per hour. Let's imagine the total time took 10 seconds for that car to come to a stop. We can rewrite our initial velocity in meters per second, which is 13.89 meters per second. Final velocity is also 0 meters per second. And now we're going to write our equation. Doesn't change, it's still acceleration equals the change in velocity divided by the change in time. We can rewrite the change in velocity as final velocity subtract the initial velocity, all divided by the change in time. But what happens now is when we substitute our values in, we go 0 subtract 13.89 meters per second. That's going to give us a negative number in the numerator. We're going to divide by 10 seconds. When we do that calculation, just to clear up some space, when we do that calculation, the acceleration is going to equal negative 13.89 meters per second divided by 10 seconds. And that will be negative 1.389 meters per second squared. We have to go back and check significant figures. 50 kilometers per hour has one significant figure. 0 really doesn't have any, and 10 seconds has one significant figure. Our acceleration has to be written in one significant figure. We can simplify that to -1 meters per second squared. And as a very simple and quick review, acceleration, when it is positive, that means the object is speeding up. And when acceleration is negative, that means that the object is slowing down.